Alright, so today we're going to talk about process planning. So once you've got a set of drawings, how do you plan to make it? So what do you do to figure out what do you need to do and in what order and all that? So that's process planning. First thing, we need to have a good bill of materials. So what is a bill of materials?
The list of all the things needed to make that part?
Yeah, the list of all the things needed to make that assembly, right? So it's going to be kind of a table, and we're going to have maybe like the part number, right? Part number, a description.
Quality. How many you gonna use?
Yeah, quantity. Quantity, what else? And this might be more than what we put on the bill of material on the drawings. On the drawings, we've got a little bill of material too, right?
What it's made out of?
Here we've got a bigger one. So yeah, material.
Material. Yeah, material what it's made out of.
What else? What else would we like to know just as an overall of all the parts? What?
Price?
Or specifications?
Maybe if it's a purchase part. Yeah, so. And we can even calculate that for manufactured parts too, right? So, price, what else? What else would be good to know about the overall? So, part number, description, quantity, material, cost. Yeah, if it's a purchase part. So that could be self, or it could be who you're buying it from. What else? There's something else we're missing. What would be a good thing to know about something just to be able to look at it from a table? There's two more things I'm thinking about.
Item number?
That goes back to the part number. So maybe that's part or drawing number. That could be two different things. What else?
I don't know if this is it, but I know like at Westmark they had, if it's an assembly composed of multiple different assemblies, they had a section that said whether the part you're adding in is a part, a single item, or a sub-assembly.
Oh, that might. So that would be a good thing on this also. And usually the way I handle that is, and so that's in the, depends. It could be a checkbox for part or assembly. So on mine, when I do it, I usually keep like my numbering system. I use full digits for assemblies, dashes for parts, and then I'll sometimes break down even further than that. So like under this weldment, it was 2-1 is the weldment, then 2-2, T, 2-2, 2B, 3L, 3S. Those are the parts within that. So you can kind of, depending on how you want to figure out the numbering system, that could be part of it. And also, I do like indents and stuff to help do that also sometimes. So you can also call it a core sheet, but maybe put some more stuff on it. But that might be part of assembly. What's another one that we might want to put?
I know this could probably go under description, but like if you're using bolts and nuts, thread and pitch,
Yeah, that'd probably be
that
in
would
the
under
description.
description, right? Color?
What else? What?
Color?
So finish.
Finish?
So that was one of the two. There's one more thing I'm thinking about that we should probably put on that list.
something having to do with packaging?
No, this is for parts that we're making.
So if it's, would you put it on if it's cast molded or would you put that on there?
Not really, but that kind of goes into it. What?
That's already more than I was put on mine.
And so maybe size, right? So the raw size.
The length?
Oh, yeah,
Oh.
overall dimensions.
Yeah. So. So what I'll be is when you're starting the process. So is it going to be a piece of, so like,
Well,
we have a,
that could also be used, that way if you do need to package it, you know the overall size, you
Yeah.
know what box to get.
yeah, and then you can also have a finished size. Because if this was here, and that was 1 7/8 by 2. Sure. And then that's like half an inch, whatever those are. And then it's a 1/4 inch thick. That could be 1/4 inch plate, 2 inch, or it could be 2 inch by 1/4 inch strip, and then have it cut here and sheared off. So there's a few different ways we could make this, but what size are we going to start with? So you'd probably start with a 1/4 by 2 by 1 7/8. That'd be your raw size. So you get something like that. So that way you know where you're starting with the material. And so a lot of this you can get from the drawings themselves. So like on that part, we can see the overall size of it. We can look down here and see the material. We can see the part number, the title. So we can see all that stuff and kind of pull that into this one sheet. And I usually like to do this final bill of material in Excel. That's a good place to do it. Some people will have a template set up in Word to fill it in. Yep.
Doesn't Revit or Inventor and AutoCAD both have a feature for that? They both have a...
Yeah, and you could also use the bill of material feature within Inventor and add these extra fields. So you just do one bigger bill of material. So you'd have one bill of material for the drawings that's kind of condensed, and then one larger bill of material for a title page. So just by bringing in the other fields. So it could be done that way too. Or it could be done out of a PLM system, a database that organizes all the drawings depending on how they're doing it. But whatever it is, usually you'd want to have something like this, or either you'd give it to the shop, or the shop would have to make this on their own, so they know what kind of, all the different pieces of what they need to make the final thing. And for each part, we want to do an operation sheet. So we want to figure out what we need to do to make each part. So we put in the part name, the number, material, drawing number, and then we'd figure out what operations do we need. Like on this one, let's go to just that one. So on that one, what would probably be the first operation? So actually, before that, what material do we use for this?
Steel.
So we have steel. What type of steel? I mean, what would we start with?
Right, cube.
Yeah, you'd start with something that's 1/4 inch. We'd see if we can get some strip, or do we need to get a sheet that's bigger and sheared, or cut it out with a plasma to get it tighter. So if we could find a 3/4 by 2.5 inch strip, we just need to be able to cut it into 3-inch sections, or bar, right? So we get 3/4 by 2.5, we just cut it into 3-inch sections. We get 3/4 by 3, we cut it into 2.5-inch sections, right? So that'd be our first part. So we start with a rectangle. So we'd that's our material. And then operation number 1, what would that be? Sure.
Shear, cut,
Well, let's say we already got the blank size.
milling,
What?
mill,
Mill on what?
corners.
The corners. So those could be milled off. How would we mill it? Would we set it down flat and do it like that, or would we set it at an angle and just cut it off?
Depending on what.
Depends on your tooling.
Yeah, depends on your tools.
So it'd probably be easier, and it'd probably be a better finish, right? If you set it up like this and then cut across like that to cut it.
Mm-hmm.
So you need a jig, right? You need something to hold that in the spot. You could also have a jig to hold it and then use a saw to cut it. You get that? Depending on what finish you wanted, right? So let's say we're going to use the mill. So operation number M1. Corners and tooling. Whatever. And maybe this is a 2-part jig. One to hold it this way, one to flip it over and hold it the other way. So you can cut position 1 to cut one side, flip it over to the other position, cut the second side. And just keep alternating through. Then kind of, how much time would that take to set up?
No more than 10 minutes.
20 minutes. That's for the setting up the machine. So putting the jig in, loading the program,
Okay.
and then the production rate. That's how many can you make in an hour. So let's say that takes 3 minutes to run, and it cuts 2 at a time. So it's basically 1.5 minutes each. So you've got, I don't know,
45.
yeah, 45, 50 an hour. What is it, 50 an hour? Because maybe you could ramp the speed up. So we'll just say 50 an hour on that. And then we move on to operation 2. So then after you do that, what would be the next thing to do?
Milling out the.
Cut out the slots, right?
Yep.
And then, so you cut out the slots.
That'd be a hard one.
And so, yeah, that slot, could they make that easier to make?
Go all the way through.
Where do we go?
Instead of it stopping.
The groove.
Oh, the groove? Yeah, go all the way through this way? Yeah, that'd make it a lot easier, right? Or if I wanted that to be blind here, just make that a radius, right?
Mm-hmm.
Don't make it square corners.
But then you'd have to change your.
And
other
so,
part too.
yeah, you'd have to change the other part. So, and that'd make cutting that other part a little harder. But cutting this with sharp corners, that's going to be really hard, right? So, that's something to look at. Okay, is this easier to make? Then they might see that and go, okay, let's do an engineering change request, send it back to engineering and see if they can change it. Yeah.
Making those corners though, like depending on what your clearance tolerances are, you know, like if you have, you know, pretty big tolerances, it doesn't have to exactly be a corner.
But this is pretty tight.
Yeah,
It's pretty tight fit.
it is. But I'm just saying it all depends, right, on the part. Like
Yeah.
if the tolerance is
Yeah.
forgiving,
Yeah.
then you could always leave a little bit of a radius there.
Yeah. And it could also put a smaller radius, and that'd be easier to do on the other part also. And then that way they can come in with an end mill that's maybe 1/8 of an inch or 1/4 of an inch. They can do a pass there, come around another pass. So they put a 1/4 inch in the mill, that'd be a 1/16 of an inch radius there, right? Or 1/8 of an inch radius. So that'd give them a little radius, make it a lot easier to machine. So we do the next, go back to our operation chart, put in that, and then you probably have it cut that, drill and tap on the mill, just in one operation. Or you can take it over, drill press it, but probably easier just to have it, cut it, do it, drill it, tap it, all while it's in the machine, right? And again, so we'd have Yeah, and if you had a 4-axis, you could have it spin it. If you were 5-axis, you could just do it all. So depending on what machines you had, you'd do it differently.
It's gonna take a little longer to set up. Only 20 minutes on that much?
Yeah, because it's still just changing a fixture plate.
Oh, okay.
And then
But
this is a little bit longer, so we'll do 30 an hour. So now it's got to mill the slot, drill it, tap it, go to the second one, do the same thing. So we're just making up time right now.
The more steps, the more,
Yeah,
less you need.
Because there's 2 slots in each one, so you can.
yeah. And we'd still have another 2-position jig. 'Cause that's really specific. So instead of doing all the left side and then all the right side, you do a jig where you've got the jig set up. You got a slot here for one and a slot there for another one. Or even maybe you got multiple, 2 for the left side, 2 for the right side, whatever it takes to fill up the table in the middle. And that way you just load it, you hit go, it does more than one part at a time. And you take all the parts out, put a whole new batch in. Then you can have the machine running longer at one time. So we do this. So after you figure out that, we'll do a flow process. So how's it going to move in the shop? Or task 1 is M1, and that's an operation. And then after we get done the mill, the first mill, is it going to go, what's it going to do? Is it going to go somewhere for storage? Is it going to go move to another mill that's doing the second operation? What's it doing? So maybe we've got one mill that's doing the first operation, a second mill that's doing the second operation. So now it's going to transport, and then we'll have mill 2 in the second operation. So that's
Wouldn't it, if like if you do mill it once, right? Before you keep going on with the processes, wouldn't you want to inspect it? Make
Oh.
sure that process is good.
that might be a good thing. So instead of
That
going
way
straight
you
to the
don't-
mill, you do an inspection there.
Wouldn't that depend on like the tolerances hard for that operation?
Yeah,
Because that was just cutting the corners, they're cutting the corners might not be.
yeah. So kind of those corners might not even be important. So
It's just like.
because that's just an appearance thing. But if the slots was first, then yeah. And you might want to inspect it first to make sure that it's square. So, right, because that part had some pretty specific tolerances for parallelism and everything. So you might want to do inspection first, or maybe it need to be face milled first to make sure it's true before you started cutting on it. So maybe we would actually want to start out of a bigger piece so we could cut it down to the right size. So we'd want to start out of a 7/8 by 3 inch piece by a little bit longer than 3. So we can cut some material off of it, or 3 1/4, or 2, or 2 and 3/4. What?
Whatever your shear allowance.
Yeah. Yeah, so make sure you got enough space that it's gonna come out right. And tighter the tolerances, you're gonna have to waste a little bit more material because you can't start with just the raw material usually. So we'd put that in, put it in the machine, put it in again the tooling that we were using, so the jig numbers. So now we can see how it's gonna move through the shop. When we're gonna have inspections, does it gonna get delayed somewhere? Is it gonna go to storage sometime? So are they gonna do a bunch of these and store them, and then pull them out and come back to them? How are they gonna do that? Okay. So questions on this? For the next one, we'll do an operational chart. So now we'll take, this is, before we were looking at just each part by itself, now we're looking at the whole assembly. So each one of these columns is a part. So now we're just gonna put in the operations that are being done on each part. not worrying about transportation or delays or any of that. The number in here, that's the number from here. And so we can kind of see how they come together when they join for assemblies, when we have inspections, kind of going down the whole process. Okay.
One piece just
What?
skips inspection.
What?
The wood seat just skips inspection.
Yeah, that's probably a purchase part, right? Right. It has no processes here. It just comes straight down,
To assembly.
Straight
jumps
over.
right into an assembly.
Splink.
So that's a purchase part.
Yeah. And then shit
Is that
carton.
what that line is? They just hopped over that like.
Yeah.
Yeah,
It's just like on a
Yeah, when-
circuit.
yeah. The little thing here means that they don't actually connect.
Yeah.
That means that they were too lazy to draw it there.
You'd be surprised. When I was working at Foster Farms, like this badass, supposedly engineer for water lines, we were supposed to put a valve in to shut off city water. He didn't do that on any of the crossings, and there's like in his blueprint, there's like 10 of 20, you know. So it's like,
So you
is
think
that
you
gonna-
have all these?
Yeah, we didn't know if that
Cross-
was it. Like, it's like, dude, are you serious? My boss
Put in a
was
bunch of
pretty
unions.
pissed.
No
Yeah.
water pressure.
So,
Yeah, it's like, is this a
You got
T
this
or
going
is
this
this
way,
going
that
over?
way, that way.
Yeah.
so also,
Just connect them all together. It'll work.
also if you notice here, in the parentheses it has how many there are for the assembly. So there's 2 of those, 4 of those, 4 of those. Here we have a left-handed one and a right-handed one. So like on these chairs, the arms, the left and the one that are yes, these ones. on
No,
chairs
you're
that have
talking about
arms,
They're different.
you have a left side and a right side. You know they're exactly the same, but they're mirror images. So you do just a drawing of one, and you tell them to make left and right. So like left side's shown, right side opposite. So they know we can just flip it over and make the other side. And so that's what they did here. And there's a left and right. So we kind of know what goes together. Okay, questions? And then if you have a shop, you'd also do a flow diagram. So let's see. So like there's a shop, and you've got there's mill 1, mill 2, whatever, you have all the equipment laid out on the shop,
And you'd want it
and then you
accordingly.
do
Because you want your mill 1 at this corner and your mill 2 at the bottom corner.
yeah.
And then having to run it back over here to store it and run back over here to...
Yeah, and so that's part of how's the shop laid out. Some of the, if they're making the same kind of thing, they'll usually group things to make it easier to make whether it's going to be all the mills together, or they'll do machine centers where you've got a mill and a lathe and a bandsaw all right next to each other, so you can go from the bandsaw to the mill to the lathe, and keep it all just real close. And it depends on what type of product they're making. Do they want to have all of the same type of machining together, or do they want to have different clusters around? But you'd actually draw out to show kind of where things are going. Okay? So that's the flow diagram. So, any questions? Did you guys have a class project today? If you can guess what it was.
Do that.
Yes.
Do not.
You are going to do an operational sheet for
A class project? So entire
a
class?
class lab. All of you, you're going to figure out how to break it down by people.
Wait.
Yeah, I know we're missing the part of it.
Yeah, we're missing quite a few.
Well, the people that are here are going to get credit for it.
That works.
So, you guys need to get together, figure out how you're going to break this down. I've already got it broken into sub-assemblies and everything. So you need to do,
Make the whole part, or do
You got individual parts, then assemblies, and then
yeah, so I want
main
the,
assembly.
I want the operation sheet for each part, the flow process chart for each part, and then the operation process chart, the big one, for the whole assembly.
Let's just do sometime next semester.
Let's do it Thursday. we're gonna talk about it. Also, I included this little chart. And actually, in the H folder, I put a subfolder called Process Control that has the device drawing assembly. I have this chart here on finishes, so that for the specific tolerances, you can see what types of processes can make those tolerances. So if you have something that's 8 thousandths of an inch, you're not going to be able to just mill it. Or 8 10,000ths of an inch, you're not going to be able to mill it. You're going to have to come up and do.
Most of our stuff only goes to thousandths, though, right?
I've got some pretty
There's
good
one
tolerance on this.
10,000ths, I think.
I also put an operation sheet on here for you.
Yeah, ours just goes to thousands.
Oh, you can add extra lines, right? You can just right click and insert a row. Add more rows if you want. Right? Just right click,
Nope, there's one to thousands.
insert, row above. Just do that. If you need more rows.
But we have it noted right here how. what's our
And I
tolerance.
also have the flow chart as an AutoCAD drawing. So,
Just put the text in there.
yeah. I didn't put any text up here, so you're going to have to put that in. But I did put
We'll just
it in
copy
here.
that one.
So you can just take this one and copy it down for all the rows
Copy
or
it.
array it. And then you'd have to put in your own text up here.
So how
You
we
might
do
want to
this,
put the
guys?
text in here, have someone put the text in, save it, and then pass off, then give it out to everyone else. You can also change these over to attributes if you want. That'd be,
We all have to have our own. The one that we need to turn in.
yeah, you're all gonna do your pieces and put them back all together, and we'll go over it all together next Thursday.
Oh, so we're doing device, and just pick a part we want to talk about.
No, the whole, you guys need to break it apart yourself into what parts that you're doing.
Well, there's a double part.
So, all right, it looks like the group's starting to get together.
It's like 16 sheets, parts.
Yep,
7,
but that's.
And there's only 5 people.
Okay, so that's 3 parts each,
9.
but that's including assemblies and sub-assemblies.
Yeah, that's too much.
Plus the pins.
You're not drawing them.
Well, the pins are.
We're not drawing them.
You're not drawing these, you're just doing the process
So you're
chart.
drawing.
Do we have to do the pin, or is
Uh-huh.
that an order in part?
That's an order
What pin?
part. Pins and
the,
screw.
the locking pin, yeah.
They ordered.
The pin right there,
Yeah,
That's
that's
order.
order in.
it's a purchase part, right?
Purchase. Ordered part. And screws are ordered.
You just need to do this for the parts that we're making.
Or so could.
So make bill of material, figure out everything that needs to go into it, do all the operation charts and everything, and have some fun.
We don't know the easy ones.
We always do.